Good morning. I think we're on page 11 of your work packet, and we're going to just think through some of these. If you've already done these problems, be sure you check your answers and always check my answers because it's possible that I can make a mistake just like it's possible that you can make a mistake. So remember, the first thing we're going to do when we attack one of these problems is we're going to find out what we know and then what we are looking for. Now, this problem is looking for grams. That means when we decide um, which of these equations we're going to use one that ends with grams right in this spot. Now, this problem down here starts with moles. That's the thing we know, and grams is what we are looking for, and it's grams of C2H6. So, now that we know that, we can decide we're going to work with this one that's labeled D up here. So remember, those will always be on the screen for you guys as you are solving these problems. Let's set this problem up and solve it. We're going to start by writing 1.2 moles. Make this a little bit bigger. 1.2 moles of C2H6. And we're going to multiply that by a conversion factor. We're going to write that conversion factor right over here. We're just going to copy the units and numbers from here, the numbers that are there at least. So here is the conversion factor. It's going to have grams of C2H8 on the top, and on the bottom, it's going to have 1 mole. So we've copied down this conversion factor, and that's moles of C2H8. Now, the reason we're looking at this very carefully to get the units in the right place is if the same unit is upstairs and downstairs, we can cancel it out. So the next thing we've got to do is find out what number are we going to put into this place right here? And that is the molar mass, the number of grams per mole of this compound. So we have to calculate that molar mass. I'm going to scoot this over just a little, and we're going to have 2 carbons. Carbon is 12.01 on your periodic table, so that's 2 carbons is 24.02. And we have 8 hydrogens, And I look up hydrogen on the periodic table, it's 1.01. And we're going to multiply that by 8. So very handy, that comes out 8.08. We're going to add those together, and that will be the molar mass. That'll be the grams in 1 mole of C2H8. So this will be 8 and 2 is 0, carry the 1, get my decimal point, 8, that's 2. And so does 32.10 look okay to you? I hope it is 32.10. That's the number of grams in 1 mole. So to find the number of grams in 1.2 moles, we're just going to multiply by the things on the top and divide by the factors on the bottom. 1.2 times 32.10. I already messed up. I put a divide there, so I've got to go back and change that to times. Okay. And divide it by 1, and I get 38.52. So on your worksheet, you're intended to write the answer over here, 38.52. And the unit that's left is grams of C2H8. So that is kind of slowly thinking through the problem and how to do it. We're going to take a little pause here for you to catch up. And okay, we're going to continue on with this recording. We're looking at problem number 12. And we're going to say, we know that we are starting with 133 grams of platinum. How many moles is that? So this time we're looking for moles and we're starting with grams. So we're going to choose equation C here because it ends in moles, and that will make the grams cancel out and end in moles. So this is the equation we're going to choose from the equations that are up on the board. And so that looks like this: 133 grams of platinum, multiply by the conversion factor from our periodic table. This time we want grams of platinum on the bottom. So we're going to be dividing by that, and 1 mole goes on the top, 1 mole of platinum on the top. So we look up platinum on the periodic table. It's atomic number 78, and it has a molar mass of 198.08, 198.08 grams per 1 mole. So calculate this. We're going to multiply by the things on the top and divide by the things on the bottom. So 133 times 1 divided by 198.08, and we get our answer, and it looks a little less than 1, right? 133 over 198 should be something less than 1, and indeed it is 0.67. And remember, we're very interested in how these units come out. That's part of what you are scored on, is showing how these units work. And the unit that is left is moles of platinum. So let's look at another one very quickly. Now, number 13, moles of silver. Oh my goodness, look at that size of that number. We're using exponential notation, of course, scientific notation. And that number is huge. That's like going to be more than the mass of the Earth, I think, when we're done calculating that. We're only calculating moles. But so we're looking for moles. That's what we have the question mark under, is moles. And we have this many molecules of silver. So we want to be sure we're ending up with an equation that ends with moles. It has to have moles in this position right here. And we're starting with molecules. So that means we are going to choose equation A. So you'd want to copy that down, copy the units down so that you get that right. In other words, I'm going to put molecules, and I'm going to leave a little more room because that's a big number I've got to write there. So I'm going to scoot over a little bit. Remember, I cannot abbreviate molecules with MOL because that means something totally different, right? So I'm going to put molecules there, just like it was in the formula up here. I'm going to put moles on the top and molecules on the bottom. And it was 1 mole on the top. And here is where you will remember we use Avogadro's number on the bottom. That's at 6.02 times 10 to the 23. It's a big number, but look at the size of this number of molecules. 7.46 times 10 to the 69th power. So what that means is, a 746 with another 67 zeros behind it. So this is going to be a big number when we get our answer. But let's look at what the units of the answer will be. The units of the answer, of course, will be in moles. So I'm going to write that over here in our answer column. Okay, now remember, I showed you how to put these into your calculator, and I'm going to put it in as 7.46. I'm going to push the second and select the EE button, and then put 69. So that's 7.46 E69 is what I see on my screen. I'm going to multiply by 1 and then divide by 6.02 second EE23. Now, if I do it differently, I'm going to need parentheses or something like that. And I'm getting, on my calculator, I see 1.2, and it would be so easy to miss. So easy to miss that clear over on the right is a times 10 in very small print, and then 46. And that's just a huge mass, a huge number of moles of silver. That's a lot of silver. Okay, let's look at number 14. We'll go through these last couple of problems real quickly. Here we're looking for moles, and we're starting with grams. This is what we know. So let me put down what we are starting with. We're starting with grams, and we want our final answer in moles. So let's see if we have an equation like that up here in the top. We're starting with grams. There it is, and we want moles. So we have to put grams down below moles. And here is our conversion factor. We're going to put grams down below moles so that they cancel out. So it means we need the number of grams in 1 mole. And so to do that, we look up hydrogen and take 2 of those, and look up water and take 1 of those. And that's going to be 18.02 grams of water for every mole of water. Now, how much are we starting with? We're starting with 36 grams. 36 grams of water. So to put this into our calculator, we're going to do 36. I almost write 63. 36 times 1 divided by 18.02, and we get 1.99. It actually is 1.997. A lot of you are going to round that up to 2.00. So I'm going to write 1.997 grams, but I'm also going to write 2.0 because either one of those I'm going to accept from you. Actually, which one is going to be on your bingo game? Let's go with the bottom one there, 2.00 grams of water, because that's what we would round it to if we were being careful. So let's move to the last one. Here's what we know, that we have 12 moles of beryllium chloride, BeCl2. We're going to multiply that by a conversion factor so that we come out in grams. Now, how would you recognize that up above? Because, grams is what we're looking for here at the end of the problem. So let's see if there's something up here that starts with moles and goes to grams. Moles to grams. There it is. You would choose equation D and you'd copy those units down, moles to grams. So let's do that. That's grams per 1 mole, so that the units here cancel out. Of course, that's moles of beryllium chloride. So I'm going to have to look that up on the periodic table, right? Because that's the molar mass. We get the molar mass from the periodic table. So we're going to be looking for 1 beryllium. Beryllium. Why don't I use beryllium very often? There it is. 9.01 is its molar mass. That's the number for 1 mole of beryllium. And we have 2 chlorines. And chlorine is 35.45. So I put that into my calculator and I do 2 chlorines, and that comes out to be 70.9. So I add those together in my calculator or on my paper, and I'm going to get 79.9 1 grams per mole for beryllium chloride. So that's what I'm going to write up here, 79.91 grams per mole. So to get this answer, I'm just going to do 12 times 79.9 divided by 1 equals 958. So I'm going to put 960 for my answer. That's grams of beryllium chloride. So hopefully by now you have all of the problems worked and checked on pages 10 and 11. And if not, you need to find some time to finish those. Maybe you weren't here, or maybe there's some other reason you didn't get them done when we were working on them in class earlier. So there you go. Hopefully that was helpful. It's time to take some kind of brain break, man. Just take some kind of brain break. Yeah.